Hello everybody. Today we will be discussing one of the auxiliary topics provided for you. So let's get right into it. A separator is a vessel used to separate gas and liquid components from the fluids extracted from an oil well. It can also be defined as a device which separates fluid into its appropriate components. It is a capital industrial tool used on onshore and offshore wellhead platforms and in the refineries. Depending on the functions of separators, they can be classified as test separators, high pressure and low pressure separators. In this module, however, we will specifically be talking about the test separators and their distinct classification. On the whole, in the analysis of both onshore and offshore wells, the test separators have a significant function. While constructing this vessel, several important design points have been determined, and those are distinctly demonstrated in this slide. Firstly, to determine oil, water and gas rates, which are important to diagnose well problems. Next, to evaluate the production performance of individual wells. And lastly, but most importantly, to take samples for the laboratory analysis. As we have already looked into the design purposes of test separators, we are now able to identify the application of these vessels and the parameters calculated with their help in various fields. However, even prior to discussing the application field of test separators, it will be better if we look at the way how the fluid collected from this unit helps engineers. The laboratory analysis of the fluid coming out of the wells provides the engineers working on the offshore all the necessary data needed to make critical decisions about a type of name separator, HP or LP. Therefore, the accuracy and precision of these data have direct relationship to the production efficiency and general costs. And because of this, it plays a huge role in the life cycle of the platform. The test separators find lots of applications in there, such as exploration of the wells, well development, resource extraction, and post-production cleanup. Before heading back to the last slide of this module, let's briefly talk about the mechanical parts of these vessels. The test separators typically comprise a vessel, an oil flow measuring system with dual meters, flow measuring system of gas, several sampling points for each effluent phase, and two relief valves to protect the vessel against overpressure. To achieve the accurate measurements, the test separator is fitted with pneumatic regulators that maintain the constant pressure and constant liquid level inside the vessel by controlling the valves on the oil and gas outlets. And additionally, the test separators are also fitted with a deflector plate, coalescing plates, a foam breaker, vortex breaker, a wear plate, and a mist extractor. Named part of the separators lessen the risk of carryover, liquid and gas line, carry under gas in the liquid line, along with increasing the accuracy of the flow rate evaluation. And lastly, the fluids used in the various industries can be diverse in phases, and therefore manufacturers of test separators have been developing the test separators in different configurations, so that they can handle more than just two phases. Let's briefly describe some of these configuration types. Initially, two-phase separators. These type of the separators aimed to remove liquid phase from the gas phase without any reference to the components themselves. Then the three-phase separators that are highly used in offshore platforms. The more advanced analysis is implemented in which oil, gas and water are divided into separate phases. And finally, the four-phase separators. That's rare to see these separators, as they separate not only water, oil and gas, but also sand from oil. I hope this lecture answered some of your questions about the test separators. Have a good day and keep following.